This is the teacher's summary for Unit 5, Lesson A. Side, 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 angle, angle, and angle, angle, side, triangle shortcuts, and informal proofs. Here we are on page 2. Don't be intimidated by the word proof. A proof is just a detailed technical explanation. It's just a detailed technical explanation. That's all it is. When we talk about a proof in math, a good proof does not simply focus on what is the answer. Instead, in a proof, we're more concerned with the how an answer is obtained and why each step is logical. So in previous math classes, this was the main focus. What is the answer? But for the next 3 days, we're going to be more focused on these two, how and why. When working with any kind of proof or explanations, you need to have this part of your reference handy. It's called your definitions, properties, theorems, and postulates, your DPTP, handy. And that's in the beginning part of your section in your ringlet, and it looks like this. It says definitions, properties, theorems, and postulates. You need to keep that handy in front of you at all times because we're going to be going through this quite frequently. You need to familiarize yourself with this. Your DPTP. And when you're working with a proof, you're going to follow the process called GIFT, which is given, implied, freebies, and talk through. That's why it's called GIFT. Given, implied, freebies, and talk through. The first part of the proof is to mark the given information and what you're trying to prove directly on the diagram. Implied. Then you mark what is implied by the given information. What do you know is true because of the given? Then you also want to talk about the freebies. Freebies are things that are true even if they're not in the given. Example, vertical angles, reflexive sides, linear pairs, triangles adding up to 180. Those are all true even if they're not in the given. It's just part of the diagram. Last and most important is you want to talk through, verbally talk through the logic of the proof or the problem before you write it down. Talk before you write. Really important you get in the habit of that. Talk before you write. So take a look here. We do the given, implied, freebies. You think about it, you talk it through, and then you write it up. Now, as you're doing your write-up, you want to watch out for really good buzzwords, almost like an English class. You should try to use these phrases. You can say something like, it is given. You might also say, also, it is true. I know something, whatever it is you know, and then use the word because, and why do you know it? So also, therefore, and the concluding place, finally, or to summarize. Notice, these are all simple, good buzzwords of a normal English writing composition. So we're going to be using concepts of English writing in today's math class. Now let's recap what your preview notes were all about. Your preview notes talked about congruent triangles. Congruent triangles are triangles that have the same shape and the same size. And when triangles are congruent, you have a total of 6 items that are congruent. You have 3 sets of congruent sides, So for example, we have 1 set sides, 2 set sides, 3 set sides, and you have 3 sets of congruent angles. 1 pair of congruent angles, 2 pairs of congruent angles, 3 pairs, 3rd pair of congruent angles. So there's a total of 6 pairs of items congruent. We have 4 shortcuts that get us congruent triangles with less than all 6 pairs. We can cut it down to 3 pairs. And the shortcuts that we can use are these. Looking at this diagram, we're going to mark one of our freebies here, and that's this. Put a triple hatch mark. Now watch. We have a pair of congruent sides. We have another pair of congruent sides. And then we have a reflexive side. So this shortcut here, this first shortcut is called side, side, side. That's our first shortcut. All 3 sets of congruent sides, congruent. In this one on the right, we have a pair of sides. And then look, we have a pair of vertical angles. That's a freebie. I can always mark vertical angles congruent. And then we have another pair of congruent sides. So this shortcut, the angle squeezed between the sides, this is called the side angle side triangle congruency. In this diagram, I call it the hamburger. Let me show you why. We have a pair of angles, and then a side at another pair of angles. The side is squeezed between the 2 angles. Let me show you here. We have a pair of congruent angles, and then we have a pair of congruent sides, and then we have another pair of congruent angles. So this one is called angle, side, angle shortcut. Angle, side, angle. I also call it the hamburger. Your final shortcut is called the tail. The reason why I call it the tail is because you're going to have a pair of angles, so think dog snout, another pair of angles, backside of dog, and then a side. So whereas this one is angle, side, angle, this one is going to be an angle, and then a side. Let me show you what I mean. In this diagram here, we have a pair of congruent angles. Then notice we have another pair of congruent angles. And third, we have a pair of congruent, it's been rotated, sides. So this one is congruent by angle, angle, side. So those are our 4 shortcuts. Our 4 shortcuts are side, 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 angle, side, angle, and angle, angle, side. What I'd like you to do is take about a minute, work through these, try to figure out which shortcut in the diagram below, retrace the angle sweeps, and mark an A. Then retrace the congruent sides and mark with an X. Mark any freebies. Determine if the triangles are congruent by side, 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 angle, or angle, angle, side. This should take you about a minute. Give you a minute 30. So you get 30 seconds each. Ready? Go. Your goal is to figure out what shortcut's going on here. Let's see how you did. Well, in this first one, we see that we have a freebie here, and our freebie is the fact that we have a reflexive pair of sides. So we put an S. Here we have a given pair of angles, we put an A, and here we have a given pair of sides, so this one is going to be side angle side. Taking a look here, let's see what we have. We have a pair of angles, then we have another pair of angles, and then we have a side that's sandwiched between the only one pair of angles. So technically this one is angle, angle, side. Taking a look at the right, we have a pair of angles, and then we have a pair of congruent sides, and then we have a vertical pair of angles. That side is sandwiched between two distinct sets of angles. So this is going to be the hamburger. This is angle, side, angle. Okay, once we have those shortcuts, we're going to talk about how to utilize this in what's called a proof. I'm going to do three more practice problems with you. So again, the question is, how do you know items are congruent? We have three sources of congruency. It's something's given, something's implied, or your freebies. Your freebies would be like reflexive sides, vertical angles, or reflexive angle where it's shared by two triangles. Let me give you an example here. Okay, so in these two triangles, the minute you have overlapping triangles, it's wise to pull them apart. So I'm going to go ahead and pull these two apart. And that should just be your habit. We have here a triangle that's B, A, and E, and D, C, and F. Okay, we are given the fact that BE and DE are parallel. So we know here that these are parallel. Parallel does not mean congruent, it means they're parallel. We're also given that A and C are congruent, so these two angles are congruent. We're also given that AE is congruent to CF. So I want to take this information. We're done with marking, hatch mark, hatch mark. We're done marking the given. Now we're going to mark what's implied and freebies. So I'm going to do this on my pull-apart triangles. We see here that these two angles are congruent, so that gives us an A. Because of the parallel lines, we also know angles 1 and 2 are congruent because they're corresponding. That gives us an A. And then A to E and C to F were congruent. That gives us a side. So I know this side is sandwiched between two distinct angles. I know these triangles are congruent by angle, side, angle. Let's try another one. You see we have triangles here that are overlapping. It's always good to pull apart overlapping triangles. So I'm just going to pull these apart right here. This is ABC, and this is BC and D. Okay, let's look at what's our given. Given, we're told that AB and CD are congruent. So AB and CD are congruent. Hatch, hatch, put an S. We're also told that BD and AC are congruent. So B to D and A to C are congruent. So double hatch, we're going to put another S. So we're done with our given. Now, if you look back at the orange and pink triangles, they overlap at exactly the same segment. That's called a reflexive side. CBC, CBC, that's another side. So I know these triangles are congruent by side, side, side. Now let me introduce you to something called an informal proof. An informal proof is where you just do a simple write-up. We're going to do given, implied, freebies, and talk-throughs. So we're going to walk ourselves through gift here. Okay, so step number 1, we're going to read the given carefully and mark it on the diagram. So let's see what I have here. We are told it is given that AB and CD is parallel with a transversal AE or EA. So we know AB, I'm going to stretch it out, and CD are parallel. That does not mean congruent, that just means parallel. I also know that AB and CD are congruent in length. So AB and CD are congruent, so hatch, hatch, that gets me a pair of sides. And last, it is given the fact that C is the midpoint of AE. So C, that's a midpoint of A to E. Okay, I am done with my given. Now I need to mark implied and freebies. Ready? It's implied, because C is the midpoint here, that A to C has to be congruent to C to E. So I do hatch mark and I put an S. It's also implied that angle A and angle C must be congruent because of the parallel lines. That's corresponding. So I hatch, hatch, and I put an A. There's no real freebies here, so I need to talk through here, why are the triangles congruent? Triangle CAB and triangle ECD. Why are those triangles equal? Well, let's talk it out. We started with the fact that we know that these two sides are equal. That gave us a pair of sides. We also knew that that was a midpoint, which gave us another pair of sides. And because these were parallel, then we also got these angles. And because those angles are congruent, I know the triangles are congruent by the side angle side shortcut. So this would be a common write-up. Remember, we have to use our proper buzzwords here. So watch what I do. Okay, so I'm going to start with the idea of what is given. I'm going to say it is given that C is the midpoint of AE. Okay, so what do I know from the midpoint? Therefore, AC, the segment, is congruent to CE, the segment, because of the midpoint. That got us a pair of sides. Next, I can say it is also given that AB is parallel to CD. So, the measure of angle A is equal to the measure of angle C because they are corresponding angles. So that gave us a pair of angles. Then it is given, was given, that AB is equal to CD. So this is our final set of sides. So we can say, finally, the triangles, let's check out what the triangles were. CAB is congruent to ECD because of the side angle side congruency shortcut. That's called an informal proof. You just record the logic of your thinking, sentence by sentence.